So, yeah, it was fine, dude. All right. So, it is Wednesday, so it's kind of a weird question. All right. So, chapter 3, we're going to be talking about graphing. Specifically, we're going to start with graphing sine and cosines. So, this first section is going to be mostly just kind of an information dump. So, we just have to define some like basic characteristics. We got to talk about some new vocabulary to describe parts of our graph or attributes of our graph. There's not a whole lot of there, but it's important information nonetheless. So let's start by talking about sine. And to do this, we'll start by looking at the graph of sine. So I'm just going to go to my calculator, make sure that my mode is in radian, and then I'm going to type in sine x to the y equals, and then do the zoom trig command, and it'll give me a nice picture that looks kind of like this. So for sine, my parent function is going to be, not surprisingly, y equals sine x. The domain for this function, if I think about what we did last chapter for sine, we came up with this point definition for sine. And the reason we came up with this point definition of sine is it allowed us to take the sine of any angle, regardless of whether it was negative or positive, or how big or small that angle was. We could still take the sine of it, right? What does that tell me the domain is? It's all real numbers. If I can take the sine of any angle, the domain has to be all real numbers for y equals sine x, right? If I look at the graph, though, definitely the range is not all real numbers. It looks like there's a minimum maximum y value involved here. So it turns out those minimum y value is -1 and the maximum y value is +1. So the sign is stuck there in between -1 and +1. So if I look at this graph, we talked about symmetry back in the first chapter. We talked about 3 kinds of symmetry: symmetric across the x-axis, the y-axis, and 180-degree point symmetry about the origin. Which one of those 3 symmetries do we have here? I do really want an answer. It's a 1 in 3 guess if you're feeling adventurous. It's across the x-axis, y-axis, or 180-degree point rotation about the origin. It is the 180-degree point rotation about the origin. We called that functions that have that attribute, though, we called them odd functions. So I'm just going to use the odd moniker there. The idea was if I take the graph and I split it in half and I reflect across the x-axis and then the y-axis, I'm going to land on the other half of my graph, which is what we'd see here, correct? All right? All right, let's talk about the continuity. That was something we talked about in the first chapter. If my domain is all real numbers, what does that tell me about the continuity? Nothing necessarily, but in this case, are there any jumps or gaps or asymptotes on this graph that we can see? No. So that tells me this is everywhere continuous. Just keep in mind that you can have a function whose domain is all real numbers. It's not everywhere continuous. Now I'm going to list 3 things that I know we haven't defined yet. We'll define these in just a moment. They are amplitude, midline, period and frequency. And I'm just going to write down the values for them right now because they don't make a whole lot of sense unless you've defined what these things are. So I'm not even going to bother talking about what the numbers mean because we haven't even talked about what the term means. And it's kind of silly to talk about what the number means if we don't even know what it is that we're talking about, right? I thought so. So let's define some things here then. We have 4 things that we need to define. The first one is the amplitude. And we say that is the amplitude is half the total height of the wave. Just as an aside, graphs like sine and cosine, we call like a sine wave, because if I look at the graph, it kind of looks like a wave on the ocean where it has crests and troughs to it, I think is the term. The crest being the high point, the trough being the low point. I think that's the geological term. I'm not a geologist by trade. Just a fan. So algebraically, the amplitude would be y max minus y min divided by 2. Right? That's going to give me the total height divided by 2. The next is the midline. This is the average value for the wave. So by average value, basically we're talking about the horizontal line that's going to divide the graph in half. So in our case, the x-axis divides this graph in half. I have about half the graph above the x-axis and half the graph below the x-axis. Does that make sense visually? Can you see that? Got half above and half below. So if I do that, that's the same thing as doing y max plus y min divided by 2. The period is the length of one full cycle of the wave. So if I take a look at my graph, I'm going to pick an arbitrary starting point to look for a cycle. The arbitrary starting point I'm going to pick is just the origin because it's easy to deal with. So I do an up part, a down part, and then I start another up part again right here, right? So my period is going to be from the origin to this spot on the x-axis. So if I look at my window here, that spot on the x-axis is my x max, which is this weird looking number here, but it's not really that weird looking. I recognize this number as just 2 times pi. Right? So that's that. So in our case, the period was 2 pi. And then the frequency, we say, is the number of wave cycle, or number of cycles a wave completes in 1 unit. So that's not terribly meaningful to me. What's often much more useful is that the frequency and the period are reciprocals. So the frequency is just going to be equal to 1 over the period. I see a lot of people still writing, so I'm just kind of pausing here and waiting for people to catch up that are writing and color coding and highlighting and all that jazz, being super organized, or very artistic, or maybe a little bit of both. All right. What I'm going to do now is I'm going to go back to this list and do the same thing for cosine. I'm just going to write mine in red right next to it. You can make another list or you can add on. It doesn't matter to me what you do. Cosine. Let's look at the picture on our calculator before we get going here. So I'm going to just turn off the graph of sine and then type in cosine. Do you guys know how to turn the functions on and off on the calculator when graphing? You just move over and press enter to highlight or unhighlight the equal sign. So if the equal sign is highlighted, that one will graph. If it's not highlighted, it won't. So you can keep something in your calculator without having it show up if you want to look at it later. So here's the graph of cosine. Looks almost the same as the graph of sine, doesn't it? What's the only difference here? Would it help if I put them both up at the same time? Sure. I'm going to graph the sine with the fat line. So just when you see the fat line come in, that's the sine graph. Allison. Okay. So, yeah, can we kind of package that same observation together in terms of a transformation? What would you say that is then? Sorry to put you on the spot. You were brave enough to volunteer, so I think you're brave enough to get like a little bit of picked on here. Just a little, though. Yeah, just it looks like the cosine graph, which is the thin one, has been moved to the left maybe some amount. You agree with that, everyone? Okay. Is there anything else changing other than just translated to the left? I agree. So if the cosine graph is just really the same as the sine graph being translated to the right, would the domain change? No. How about the range? Okay. What about the symmetry? Yes. So if I look at the thin graph, what kind of symmetry does this one have? Symmetric about the y-axis. That's correct. We had a name for that. We called those functions even functions. But then everything else would be the same. I'm just going to do that. I got tired of writing the word same. So the only thing that was different between the sine and cosine function, as far as these descriptors went, was the symmetry. Now clearly their graphs are different. Let's not be mistaken, although they're very similar. Angela. That's the ditto mark for like the same thing. I was just mixing my shortcuts. Sorry about that. Good question, though. If I write a symbol you're not sure about, please ask. It's probably just some like Kulickism shortcut, but yeah, or something I made up because I didn't feel like writing the whole thing out again. But again, if you don't know what it means, like, it's not a very helpful shortcut because it's a shortcut to nothing. So please ask. I'm happy to let you guys know. All right. So let's figure out that transformation in general here. So to me, if I look at this, it looks like cosine has been shifted to the left this much. Do you guys agree with that? That it's like that little section there is what we've shifted? That is actually lining up with the tick mark here. If I go to my window, I can see that that tick mark is 1.5707, yada, yada, yada. I recognize that number. Do you recognize that number? 1.57, yada, yada, yada. It's pi over 2. So, since it's left, our h value would be negative, so minus a negative makes positive. So we'd say that cosine is the same thing as sine of x plus pi over 2. What do you think there? Not impressed. That's fine. You guys came up with that on your own. That was pretty good. Another definition. So this word is called sinusoid. That's a U, sinusoid. Just like it's pronounced. It's spelled the same way. So we say that a function is a sinusoid if it can be written in the form as some transformation of the sine function or some transformation of the cosine function, where those coefficients a, c, h, and k are just real numbered, and the a and c are non-zero. So if I look at those two equations there, those should look kind of familiar. They are literally the transformation function that we studied in the first chapter, correct? It's just being applied specifically to the parent function of sine or cosine. Is that, you guys can see that? It's the same as that transformation function we've talked about. Yeah, all right. You're not impressed still. So, what if I want to do the domain, range, amplitude, midline, period, and frequency for these transformational functions? So let's think about the domain. The domain in our parent function for both sine or cosine is all real numbers. If I stretch or shrink that vertically, is it going to change the domain? No. If I shift it up or down, is that going to change the domain? No. If I shift it left or right? No. If I stretch it or shrink it left or horizontally, is that going to change anything? No. If I do a reflection, is it going to change it? No. So guess what? The domain is still all real numbers. Oh. How about the range? If I do a transformation on that, is it going to change? Definitely. Which coordinate is the range talking about? The y's. What coefficients affect the y coordinate? A and the K. I'm referring to the general transformations of sinusoids that I'm just talking about here. There's not a problem. I'm talking about this. So you remember our transformation map? The x or c times x plus h comma a times y plus k. If I do a times y plus k to my previous range, that's going to give me my new range. Almost. So I have to take the absolute value of a to make sure that the order of the coordinate, or the order of the lower bound and upper bound still makes sense, but so the old range was -1, 1. If I take -1, I multiply it by a and add k, I just get k minus a. If I take the upper bound, +1, multiply it by a and add k, I get a plus k. That's my range. The amplitude. Which kind of transformation would affect the amplitude? The amplitude is basically like how high the function gets. It's going to be the vertical stretch or shrink, right? That would affect the amplitude. Everybody agree with that? So the absolute value of a controls that. So whatever the absolute value of a is, I'll multiply it by the old amplitude, which is just 1, so it becomes the absolute value of it. What type of transformation is going to affect the midline? No. Not a stretch or shrink. Will not affect the midline. So if we think back, so let's just look at one of these at a time, just for clarity's sake. So here the midline is at 0, right? Everybody agree with that? If I stretch it horizontally, is the midline changing location? If I stretch it vertically, midline's not going to change location. If I shift up or down, though, that's going to change the midline's location. So the variable or the coefficient I'm concerned about is the k. That's going to give me my midline. Which of the coefficients is going to affect the period? Which direction? Horizontal stretches and shrinks would affect the period. Which coefficient controls the horizontal stretch or shrink? The c. So the period is just going to be 2 pi times that absolute value of c. And then we said their frequency was just the reciprocal of the period. This is some important stuff. This is going to be one of the major tools you're going to use to do most of the homework. Is going to be this information here. So this is some important stuff. So let's do a couple of examples just to kind of practice using this information here. So on these examples, I'm going to ask you to describe that transformation and then to list the domain, range, amplitude, midline, period, and frequency. So to describe the transformation, I'm going to start by identifying the values for A, C, H, and K. What's the value for A in this problem? -4. And the value for C? It's 1/2. It's the reciprocal of the coefficient on X, is the C. H is 0, and K is 1. Everybody okay with that idea? So to describe the transformation then, I'm just going to do the 1, 2, 3, 4, 5, 6. So 1 and 2 are about the C. Since C is positive, I have no reflection. And since the absolute value of C is less than 1, I have a horizontal shrink. Since the A is negative, I have a reflection across the x-axis. Since the absolute value of A is greater than 1, I have a vertical stretch. Since H is 0, there's no translation left or right. And since K is positive, it's up. And because it's 1, it's 1 unit up. Everybody okay with that idea? Let's just take a look at the graph here, just to kind of convince ourselves that what we're seeing is correct. And I'm going to graph the parent function as well here, just so we can have something to compare it to. The graph of sine is going to come in with the fat line. So here's our parent function. And here is our new function. So it definitely looks taller. It's been stretched vertically. Everybody agree with that? It's been shrunk horizontally because I noticed that in the time it took to do 1 up and down, I get 2 up and downs now in the same amount of space. Did you guys see that? It's been moved up 1 unit, I can tell, because like the midline would be here, which is, or for the new function, right? Kind of midline comes through in this area here. And then because my parent function starts with a crest, but my transformation starts with a trough, that's the reflection across the x-axis that I'm seeing. Does everybody kind of agree, looking at our two pictures, comparing them, that this looks like what we predicted? Okay, fair enough. Right. So what's the domain going to be? It's a trick question. It's really easy. Yeah, all real numbers. When you know, just shout it out. How about the range? So that was k minus the absolute value of A, k plus the absolute value of A. So that's going to be 1 minus 4, comma 1 plus 4. Everybody okay with that? The amplitude is just the absolute value of A, so that's 4. The midline is y equals k, so that's just going to be y equals 1. The period is 2 pi times the absolute value of c, so that just becomes pi. And then the frequency is the reciprocal of the period, so that's just going to be 1 over pi. do one more just to make sure. Make sure we got it. But that shouldn't have been too bad, right? We're just basically using these little formulas. What's my value for A here? Oh, there's a bad sign. Or you guys just... 1. There you go. How about for C? 2. Good. For H? Ooh, I tricked you. Ooh, still tricking you. Yeah, we have to factor this out. So it's really 6 pi. Brockton, you said 6, which was real close. You just forgot to say pi at the end because people said 3 instead of 3 pi before you, I think, and tricked you. And then the k is -2. Okay. So 1, 2, 3, 4, 5, 6. C is positive, so I have no reflection. Because the absolute value of C is greater than 1, I have a horizontal stretch. Since A is positive, there's no reflection. And since the magnitude of A is 1, there's no vertical stretch or shrink. Since the H is positive, it's right. And then 6 pi. Because K is negative, it's left. Not left, you doofus. Down 2 units. Everybody okay with that? So that was part 1. Part 2, what's the domain going to be? Anybody? All real numbers. I heard somebody whisper under their breath. You can say it louder so you can get credit by name on the video. How about the range? Boy, Ben. How about the amplitude? One. Nice. Ben. What's that? The midline. I gotta say y equals -2. Remember, it's an equation for a line, so I need that y equals part, but -2 is correct, Mumbles, whoever that was. Jim Ball? James, were you the answerer? Okay, so I'm going to take that as a no. Period. What's that going to be? Pi is correct. 2 pi times c. And then the frequency is just the reciprocal of the period. Are we satisfied with that? Okay. What if I want to look at a graph and come up with its equation? So let's say we have this graph, and I want to come up with its equation. So its equation, it's a sinusoid. So its equation should look like this, or it can be written like this, I should say. So to answer this question, I need to come up with values for A, C, H, and K. All right? So how could I do that? What can I use to figure out those values for A, C, H, and K? Well, I'm going to use those attributes of the graph, right? So which one would be a good one to start with? Which one should I look for first? A, H, C, or K? C. Okay, we can start with C. Which one of those four attributes relates to C? Period. So I know the period is 2 pi times the absolute value of C. Everybody okay with that? So what I'm going to do now is I'm going to look at the graph to try to figure out what the period is. So if I start at the far end, I have an up part, and then I have the down part, and then it would start all over again. Everybody agree with that? So that total distance is the period. So we started at negative 2 pi, and it ends positive 2 pi. So what is my period? 4 pi. That's arithmetic. That's okay when you know it. Just shout them all out. So I can say 2 is the absolute value of C, or that C is 2, or negative 2. I'm going to put a pin in that for now. We'll come back to determining whether I want the positive 2 or the negative 2 here in a moment. Everybody so far so good? All right. Which one do you want to find next? We have C, nope, A, H, or K left. What was that? Somebody said something. I couldn't hear what they said, though. Oh. Okay. What do you guys want to find next? K. All right. Which of those attributes relates to K? The midline. The midline is y equals K. So I'm going to look at my graph and find where the midline is. Where's the midline? Just this, right? That divides the graph in half. Everybody agree with that? So, what is my value for K? 0. So we've done C and K. What do we still need to find? H and A. Which one should I next? Not H. A. Which of the attributes relates to A? Amplitude. So just as an aside, why don't I want to do H right now? Do any of these attributes relate to H? No, that's why I'm saving it for last. The amplitude, how do I find, what is the amplitude defined as? It's half the distance between the lowest point to the highest point. So if I count, that total distance is 4. If I divide that in half, it's 2. So then my A is equal to 2 or negative 2. We're going to put a pin in that also and come back and decide whether we want the 2 or negative 2. Just not right this second. Are we okay so far? Okay. Here comes the tricky piece. I am now going to determine the sines for A, for C, and find H all at the same time. To do that, what I want to do is I want to compare my parent function to this graph. So if I went and graphed sine, it would look like this. That's one cycle of sine that's sandwiched on either side of the y-axis, which kind of matches the part of the picture that we have here. Does everybody agree with that? All right, let's start with the easy question. Do you guys see a reflection occurring here? If I compare these two graphs. Yes. Is it a reflection across the x-axis or a reflection across the y-axis? It's a trick question. You're both right. You could think about it either way. Everybody agree with that? That if it reflected across the x or the y, I'd get the same result here. So which one should I pick? Doesn't matter. They're both correct answers. Just don't pick both. In general, I usually pick positive C's and negative A's. It's kind of the industry standard, although I wouldn't mark it wrong if you did the reverse. Still correct. If they're both negative, it would be the same thing as no reflection at all. Because if I took this graph and I reflected across the x-axis and then across the y-axis, it'd be exactly the same as what I started with. No. Some of them might be, not all the time. And we'll look at the next situation as one of those situations where you can't do that. And I'll talk a little bit more why in a moment. All right, everybody okay with how I determine the sines? Okay. Now I'm going to determine the value for H. If I compare these two graphs, do you see a translation? Left or right? I don't. The reason I don't is because the point where the graph crosses the midline is the same on each of these. Do you agree with that? So I can just say H is 0. Because both graphs cross their midline at the same x value, I can just say that H is 0. I guess I don't need to write that out. So here's my answer. Is this the only answer I could have? No. In fact, there's like infinitely many answers that would be correct. If you have a correct answer, even if it's not the one that I think is the easiest, quickest one to find, I would still accept it. If I'm never not sure, I'll just graph it and see if it actually gives me the same thing as my answer. I'm like, ugh, that's weird looking. I wonder if that's right. It's easy for me to check. I just graph both answers and see if it's the same thing. Let's do the other one. I have another one. Make that nice and big for us. Okay. All right. So, in general, the order that you guys picked was fine. The order I like to do is I like to do the midline first because I know K regardless. What looks like the midline for this one? Heard somebody say 1. They weren't loud enough or aggressive enough for me to hear what it was. It was Jerry? Oh, Adam. Good job, Adam. All right, so we have that. K equals 1. Okay with that. Next thing I would find is the amplitude. What's the amplitude in this situation? It's 1. So that tells me that a is 1 or negative 1. Next thing I'm going to do is I'm going to look at the period. What's the period in this situation? It's pi, right? Right? So if I start at x equals 0 and I draw one full non-repeating section, that goes from 0 to pi. Everybody agree with that? So what does that tell me about C then? That it had to be a half or negative a half. Pi equals 2 pi absolute value C, right? Divide both sides by 2 pi. I skipped writing that out. But you can check, right? Or trust me, either one. I suggest checking if you're not sure right away why that's true. Okay. Now let's determine whether this should have a reflection and figure out the value for C. So to do that, I'm going to quick sketch in a graph of the parent function and just use my eyes. So that's one cycle of sine on either side of the x-axis. If I do the same thing here, I'm looking at, actually let me highlight, that's probably going to be better. Like that part of our function. Do you guys see a reflection? I do. If I look at the red graph, I start with a trough, right? If I look at the highlighted yellow graph, I start with a crest. Oh, I see. Yeah, you got to look at, really got to look at just one section like I've done here. So pick one section out that you're going to be looking at a transformation from. Usually I pick two that are very close to the origin like this. So the yellow and the red. So I see a reflection. So let's pick the A to be positive and the C to be, or the A to be negative and the C to be positive. Everybody okay with that? Okay. Now let's look for do you see a translation? Has it been shifted left or right? Definitely has. So what I'm going to do is I'm going to look at the point that's crossing the midline to the point that's crossing the midline. Everybody okay with that? Notice those are both the middle point that crosses the midline in each of those graphs. Do you guys see that? So to make that translation, then I'm going right some amount and then up some amount. It's this amount left or right that's going to be my h. So if I look at the scale here, this number is pi over 2. That looks like half as much. Do you guys agree with that? What's half of pi over 2? Pi over 4. So I'm going to say y equals negative sine of 1/2 x minus pi over 4, since we're going to the right. Now, if you look at the section in yellow that I highlighted here, was there any special reason I picked this particular section? No, not really. Could I have just as easily gone and taken like this section? Absolutely could have. If I did that, Notice that is there a reflection if I pick that section? No. Right? Because I start with a trough and then end with a crest on each of those. And since I'm going left pi over 4, my h would be negative pi over 4. So I'd have this answer. That's also acceptable. Nothing wrong with that answer. But even so, I wouldn't have written these as the best answer for either of these. There's actually an easier way to do this. Anybody with a guess as to what would be even easier than what I've done here? Remember, for a sinusoid, this was a possible form also, right? What does the parent function for cosine look like? If I do that, I see no reflection, and I see no translation left or right. Oh my goodness. Oh my goodness, people, sorry. Goodness gracious. Those should be 2's. Right? 1 over 1/2 is 2. Eep. And then I forgot to write the k's at the end here. Yeep. Sorry. I don't understand what's going on here. So, here's what I would say. So, what I say is usually, if you're looking for how do I know whether I should be trying to use sine or cosine, like which one is going to be easier, what I would say is if there's a max or a min on the y-axis, use cosine. That was the situation that we saw in the second example above, where I had a maximum point on the y-axis. I wanted to use cosine there. That makes it easier because you don't have an h. The second situation, if the graph crosses its midline at x equals 0, I'm going to use sine as the function. So if I go back to the first one, so the midline is here, and the graph crosses the midline at x equals 0. That's why I would want to choose sine for that one. And if neither one of those two things happen, it doesn't matter. You have an h regardless of which you pick, sine or cosine to use. I would just go with whatever your preference is. Any questions here? Now, this is a little tricky because several of these steps are pretty visual, right? but that's okay. That'll do for today.